So, hello, my dear students. Welcome back to this amazing teaching series with Teach AR. I am your teacher, Abhishek Rajput, and we are just continuing the series of science, especially for grade 9 students. So, I have created this playlist, and this playlist is completely for grade 9 student. And don't worry, we are coming with more series for grade 8th, 7th, and also grade 10th, because many of the board class students are requesting me to make a playlist for them. And in our last two videos, we have got a lot of support from you guys. So I would like to say a big thank you to all my dear students. And one of the comments was there. I read it. It was about sending work and energy chapter. Okay, so I will definitely make a video for work and energy once we are done with this gravitation. So, welcome back to this series of gravitation. This is the third part of gravitation, and everything has been explained in detail. So, come on, let's start this video with this amazing top list of topics. So, I'm sharing my screen with you. So, here we are. So, in this video, we would be talking about different topics such as thrust and pressure, upthrust and buoyancy, density and relative density. Yes, the most important, very important Archimedes principle and its applications. And then we will be definitely dealing with some questions, some quizzes to enhance our learning experience. So come on, everyone, just start this video with high energy. Come on, if you're watching this video, give me a like, share it to all your friends because a friend in need is friend indeed. So definitely share this channel, share this videos with all your friends who need to revise the topic or get to understand all these topics. Let's dive into the discussion first, and then we'll be getting into pressure. But first, we have to understand thrust. Okay, so if I read it, thrust is the force acting on an object perpendicular to the surface. Okay, and that is called thrust. Thrust means something. Suppose if I assume there is a surface, okay, and I am applying multiple forces on this from this direction, from this direction, from this direction. Okay, but any force which is completely perpendicular to the to the surface, okay, to this surface, that force is termed as thrust. So if I'm going to put this block on this sponge, and I used to put it from two different directions. Okay, first I put it vertically, and then I put the same brick horizontally. Okay, now you can see some changes in both the cases. In first case, you might see that the sponge is getting down, vertically down a lot. It is showing a lot of movement. Okay. But in the second case, the sponge is able to manage that weight of the brick. So basically, if we put anything, even if we are standing on a surface, what is the force acting downwards? We have discussed it earlier. That is weight. Okay. So here the weight of the brick is acting downwards. Now, if we put the brick like this or like this, the weight is going to be same. This area, can you see this area? This is the area of contact. What does that mean? The area on which the force is acting. The force is not acting on this area, not acting on this area. Okay. So we will only consider the area of contact where this thrust is acting. Now, in both the cases, you might see something. In this case, the case number two, where we are putting the brick vertically, the area of contact seems to be bigger. Can you see? Yes. Okay. What about the thrust applied by the brick? Thrust means the perpendicular force, and every object applies a downward force that is called its weight. The weight is same. The thrust is same in both the cases because the brick is same. But something that is changing is the area of contact. And just because of that, you can see that the sponge 1 is getting pressed more, and the sponge 2 just moves a little bit. Why? This is the concept where we talk about pressure. So pressure is a physical quantity that is denoted by thrust acting per unit area. Getting it? That means how much thrust is applied. That means how much perpendicular force is applied on how much area. This is the thing where pressure is calculated. So how can we calculate pressure? We talk about thrust and we talk about the area of contact. So pressure can be defined as thrust per unit area. That means thrust by area of contact. Getting it? So now let's talk about an interesting thing. What could be the SI unit of pressure? Okay, we already know how to find the SI units. What is thrust? Thrust is actually a force. What is the SI unit of force? You all can say Newton. Yes. Now, area. What is the SI unit of area? Anyone? Yes. So we know about length. Area, length has the SI unit of meter, but this is area. So we always find the area in the terms of meter square. Yes. So the pressure have its SI unit that is equals to Newton per meter square. I hope I'm clear to everyone. Newton per meter square. And this is also known as, many of you are correct, that is also known as Pascal. Okay, we represent it with P and small a. So this was named on a scientist, that's why it's represented in capitals. So we can find out pressure in Newton meter square or Pascal. They both are the same things. Come on, let's see a real life example of this pressure. Now you can see in this first picture, there's a person standing on sand. Okay. And whenever you stand on sand, you might see that your feet just sink deep into the sand. Yes. But what is the force acting on the sand? We all know that whenever we stand or whenever we sit, whenever we sleep, we our body is being attracted by earth, and the force that acts downwards is our weight. Yes. So if I am standing, my weight is same. If I am sleeping, my weight is same. Yes. Now let's take the example of this second picture where the boy is sleeping on the sand. Yes. In this, what is the change? Is the weight gonna change? No, I would say the thrust is same, equals to the weight. What is the thing that you have noticed has been changing in this? You can see what is the area of our feet. I think our feet covers a very small area. Yes. And what about the area of the body? If we lie down, it's a huge area as compared to our feet. So here we can say that the area has increased, and that is why when we sleep onto the sand, our body does not sinks down. But when we stand on the sand, our body sinks down. Why? Because we have just noticed something about pressure. So pressure is equals to thrust upon area of contact. Yes, that means if the pressure will increase with thrust is directly proportional to the thrust. If the thrust will increase, the pressure will also increase. And pressure is inversely proportional to the area of contact. What does that mean? That means if the area of contact will increase, the pressure will decrease. This is the beauty of inverse proportionality, right? So in both the cases, what do you think? In which case the pressure is maximum. The pressure is maximum where the area is less because the thrust is same in both the cases. So when the area reduces, the pressure increases, and when the area increases, area of contact actually, okay, we will not consider this area. We will not consider this area or that area. We'll only consider that area which is in contact with the surface. Getting it? So if the area of contact will increase, the pressure will decrease. Yes. Let's move ahead. Okay. I have a good question for all of you. Let's have a look on this question and just get an understanding of it. So a block of wood is kept on a tabletop. The mass of wooden block is 5 kg. The mass is given. Okay. And its dimensions are 40 centimeter, 20 centimeter, and 10 centimeter. What is this 40 centimeter? We can say the length is 40 centimeter, the breadth is 20 centimeter, and the height is 10 centimeter. Okay. So find the pressure exerted by this wooden tabletop, by the wooden block on the tabletop if it is made lie on the table with its sides of dimension. Okay. Look at the picture. This is the wooden block, and this is the same wooden block in both of them. So, what is the thing that remains constant? So, mass will remain constant for both the blocks because both of them are same blocks. But the thing is that in case one, you can say that the area of contact is this. This area, yes, the area of its bottom, okay, the base. Okay, this area is in contact. And in this, if I talk about, okay, if I talk about it, you can see that this area is in actually contact. Which area? The area of the base. Okay. So in both the cases, you can see the area is different, but the thrust is same. In this question, we can take G equals to 10 meter per second square so that we could calculate the weight. Uh-huh. Okay. So let us just talk about case one. Okay. So in case one, you can say the thrust. Thrust is what? Thrust is the weight. Yeah, weight of this block. Okay. So weight is equals to mass into acceleration due to gravity. Mass is 5, G is 10. We got 50 Newton of thrust. What do we got? We got 50 Newton of thrust. Okay. Next, if we talk about the area in case 1, in case A. Okay. What is the area? I think the base looks like a rectangle. Okay, with the dimension 20 and 10. So what is the area of base? Area of contact actually. Area of contact is just take it as a rectangle and do the calculation of area. That is length into breadth. Okay, don't get confused with this length and breadth that I have assigned. Okay, for different surfaces it would be different. Okay. So for the base, the length is 20, the base is breadth is 10. We got 200 centimeter square. Okay. Make sure you are getting it right because this is not in meter square, it is in centimeter square. So whenever we will calculate this, we have to convert this into meter square. How can we convert it into meter square? Okay, if I have to convert a centimeter into meter, I will divide that with 1000. Yes, or 100. Yes, 100. Okay. But if it's not only centimeter, it's actually centimeter square. So we have to divide it with 10,000. Yes, getting it? You can also write it like this. These two zeros would be cancelled. We can say 2 into 10 to the power minus 2 meter square. So this is the area that we got. Come on, let's do the quick calculation. So let's talk about pressure. Here pressure is equals to, come on, thrust upon area of contact. Yes. Okay. Yeah. So thrust is 50 Newton. Okay. And then area of contact is 2 into 10 to the power minus 2 meter square. Come on. Let's cancel the things. So 2 times 1 and 2 times 25. And if we talk about the final answer, we got 25. When this 10 to the power will go in the reciprocal, it will become 10 to the power positive 2. That is exactly equal to 2500 pascals, or we can also say Newton per meter square. Yes. So this is 2500 pascals. And what would be the case if we talk about the pressure in case B? Uh-huh. So in case B, the thrust is same, only the area of contact is different. Okay, you have to find out this. Okay, and then you would be able to find out the pressure applied in case B. Getting it? Now, if I look at this, if this question appears in objective type question, what do you think? Which area is greater? I could say that this area, the area of the area of contact in figure B seems to be greater because this is a rectangle. 40 multiplied with 20, the area is 800 centimeters square. So this area is bigger. So if I have to give a quick answer, in which of the cases the pressure is more, in A or in B? So the area is less in A, so the pressure is greater in A as compared to B, because both are the same blocks, same thrust is there, and if the thrust is same, we can determine the pressure on the basis of area. More the area, lesser the pressure. Lesser the area of contact, higher the pressure. Okay, let's move ahead. I hope everyone got this beautiful concept. And this is actually a NCRT question. Okay, now let's talk about pressure and in fluids. Okay, fluids means anything that have an ability to flow. Many of our students just have a misconception that fluid means liquid, and also they just have a misconception that it's only talking about water. No, liquid or gases, because gases also have the ability to flow. Okay. Now, after this, what is the pressure exerted by a fluid in a container? Okay. So the pressure exerted by a fluid in a container is transmitted undiminished in all direction. If I ask you in which direction a fluid applies its pressure, you could say in all direction on the walls of the containers. Okay. So if I talk about this liquid, suppose this is water in this container, in both the containers, you can see what is the depth in first case. Let's talk about it. Here you can see this is the depth in case one. Uh-huh. And after this, look at the figure two. This is the depth in case two. Okay. So if we talk about these two openings in the container, you will notice that in case one, the pressure is less because you will see that the water will exit with a less pressure as compared to figure 2, because it has more depth. Yes. So if I talk about liquids, the more deeper you go in liquids, okay, the more deeper you go in fluids, okay, the more pressure you will experience. Okay. So we can also take example of divers when they dive very deep into the oceans. Okay, they have a lot of water on their head or above them, and that creates a pressure on their body. So more deeper you will go, more pressure you will experience. Okay. We can also take a recent example when there was a submarine or a kind of group of researchers who were looking deep into the sea, looking at in Atlantic or Pacific Ocean. Their submarine got imploded just because of higher pressure. Because when we go in deep inside the liquids or fluids, the pressure increase immensely. Okay, and that is why divers also have a special kind of diving suits so that they could withstand the increasing pressure when they go deep. Okay. So this is all about liquid pressure. let's move ahead. Okay. The next topic is buoyancy. This is one of the important topics and very conceptual thing in this chapter. Okay. Okay. Before asking about buoyancy, I would like to ask you some questions. Have you ever had a swim in pool and felt lighter? Like, let me explain it. When you get inside the pool, you feel that your body is feeling lighter than exactly. Okay. Next question is that, think about it. Think about it. Have you ever drawn a water from a well? Okay. जब हम पानी निकालने के लिए किसी कुएं में कोई बाल्टी या फिर कोई भी कंटेनर हम डालते हैं, तो when we take that bucket out, when it was in, it feels lighter. But when we take it out of the liquid, it feels heavier. I hope you might have noticed it. Okay. Next question. Have you ever wondered why a ship made up of iron and steel does not sink in the seawater? You can use your brain, you can brainstorm. Okay. And definitely you will get the answers of these questions. Okay. Come on, let's take one example of a plastic bottle. Can you see in this picture image? Okay. There's a plastic bottle which suppose you are taking a plastic bottle and it's an empty bottle, it does not have any water. Okay. And you just close the lid of the bottle and you try to put it inside the water. Will it sink? I don't think so. Okay. Yeah, it will not sink. If you will press it more. Sorry guys, I'm not that much well today, so that's why I'm coughing a lot. No problem. If we just try to put it deep inside the water, after some time you will notice that the bottle will come up. Oh, is this some kind of magic? We put it inside the water, why it's coming up? Yes. So that means there is something that is also pushing it upwards. What is that? That is actually called, that this phenomenon is actually called buoyancy. Here we have discovered buoyancy. Okay. Okay. Now, let's discuss about buoyancy. So, what is buoyancy? Buoyancy is an upward force exerted by a fluid on any object. It's an upward force. This upward force applied by the fluid on any object immersed in it, and it is also known as upthrust. Getting it? Or we can also call it buoyant force. In fact, every object will experience a force of buoyancy. You felt that your weight is, you felt yourself lighter when you get inside the water. Why? Because there is some force which is acting upwards. As you're acting downwards, there's a force acting upwards, and that force is called buoyant force. We can also call it upthrust. Now, the magnitude of buoyant force depends on the density of the fluid. Oh, here is one more important term that we need to discuss, density. Yes. So suppose, let's take the example of same plastic bottle. Okay. So if there was a plastic bottle, what was happening? The weight was actually acting down. Okay. And it is right now immersed in a liquid. Okay. Water. And there is some upward force which is acting on this bottle, and that force is called upthrust, or you can also call it buoyant force. Buoyant force. Oh, buoyant force. Okay. So both of them act in opposite direction. Now, if in case we have already discussed in many chapters that if there are two things, they are applying force in opposite direction, the body will only move in the direction of the larger force. So if the upthrust is, I could say, if the upthrust is greater than weight, it will apply the force and the object will keep on floating on the surface? Yes, it will float. And if the upthrust, suppose the upthrust is less than the weight, or you can say the weight is more than the upthrust, at that time the object will not be able to float. It will just sink in that liquid. There's a ship made up of iron and steel, and this is the same material, the same weight, same mass of the material. Okay, if you see the ship is floating, okay, but the sheet of iron and steel sinks in the seawater. Yes, the weight is same. Then why it's not floating if it's in the form of sheets? We will talk about it definitely. Okay. So if I talk about it, the weight is same in both the cases, but what is different in both the cases is the upthrust in this case could be different, and the upthrust in this case, in case of sheet, would be different. Okay. So it's a very conceptual thing that you need to know about density. If I read it loud, a material's density is defined as mass per unit volume. That means density is essentially a measurement of how tightly the matter is packed together. We know about matter, there are different states of matter like solids, liquids, and gas. And we know that uh, solids are very tightly packed. Yes, if I talk about the chapters that we have studied earlier in chemistry, the solids are tightly packed. Okay, liquids are comparatively loosely packed if compared to solids, but they are very loosely packed. Okay, you can also see that there are less particles in gas. We have taken same volume, but you can see the gases are less in quantity. If I talk about this first image, then you can see that liquid is more as compared to gas, but less as compared to solids. And in the third case, where you can see solids are very tightly packed with more number of particles, okay, in the same volume. So we already know that the density of solids are more than liquids and more than gases as well, right? So how do we calculate density? Density is calculated in terms of mass and volume. Okay. So if I talk about density, how it is denoted, we can also denote density with D, but in higher classes we denote it with this, that is called rho. We call it rho. Okay. So density is equals to mass by volume. What is the SI unit of mass? Yes, that is kg. And what is the SI unit of volume? Whenever you calculate volume in mathematics also, you, because if suppose there is a cube of 1 meter length, it's a cube, don't take it as a cuboid. Okay, just assume that it's a cube. 1 meter is the side of this cube. How do you find the volume? You do the cube of the side, that is 1 into 1 into 1, that is 1. And now what's the unit? Meter cube. So definitely the SI unit of volume is meter cube. So what is the SI unit of density? So SI unit of density is kg per meter cube. Kg per meter cube. Okay. And there's one more unit that is important, that is gram per centimeter cube. Okay. So if it is given in this unit, we can easily convert it into kg per meter cube. Or if we want to convert like vice versa, that is very easy to do that. Okay. Now, if anyone asks you what is the SI unit, just go with this kg per meter cube. Okay. The Archimedes principle. Okay. If I talk about Archimedes principle tells a lot about many of the real life examples. Okay. But first, what is that? We need to understand it. Now, let's take an example. Suppose there is a block of brick or any small weight or any small piece of object. If you will weight it in air, with the help of a spring balance or a beam balance, you could see that the weight was more. But when you put the same object in a liquid and then you will use the spring balance, you will see that there is a reduction in its weight. The weight has been reduced when you put it in a liquid. Okay. What is the reason behind it? Now, if I ask you where does a weight, if I put the block in air, there is only one force which is acting, that is weight. But if we put the same mass of a block in a liquid, the liquid also applies something, an upward force on that object. What is that upward force? Yes, the buoyant force. Yes. So there are two forces acting. There's first thing, that is weight acting downwards, and then buoyant force which is acting upwards. And that is why the weight in the reading of the spring balance reduces. Why? Because we are experiencing two forces, one acting downwards, one acting upwards. Okay. If the weight of the object, if the weight of the object is more, sorry, if I would say, if the buoyant force is acting upwards and the weight is acting downwards, it will definitely reduce the effect of weight. And that is why we got to see that things become lighter when they are in a liquid, just because of this buoyant force. Now, what Archimedes said about this? So, Archimedes was a very big scientist, or you can say he was a physicist. He gave a lot of things. The buoyant force, the buoyancy, all these things have been explained by, or density has also been explained by Archimedes. Okay. So, what does he say? He says that when a body is immersed fully or partially, fully means when it is completely immersed, or partially means when it is half sinking and half floating. Okay, there are some examples. Okay, it experiences an upward force. We already know that it experiences an upward force in the concept of buoyancy. But now Archimedes said that that upward force is equal to the weight of the fluid displaced by it. Now this is a very conceptual sentence framed by Archimedes. We already know that if there is a fluid, let us suppose we are taking a container. In this there is a fluid. Okay, this is the level of the fluid. Okay. And if we immerse a body in this fluid, this is the body that has been immersed in a fluid, then definitely the thing acting downwards is its weight. And the force acting upwards is the buoyant force. Yes, can I say the buoyant force will act upwards? Yes. Okay. Now Archimedes told us that how much force would act. How can we find this buoyant force? So he told that buoyant force is equal to the weight of fluid displaced by the object. Now, this is a very conceptual term. What does it say actually? So, whenever, suppose you might have heard about a very old story that's about a thirsty crow. What happens? He was very thirsty, and the level of water was this much. So, what he did, he added some stones over here. Yes. And due to adding stones, the level of water got increased. The water level will go up. So, definitely, what happened? These rocks will go down and it will displace the water. Displace means remove the water from that place. So, they will displace some amount of water. If there is a glass of water, okay, and I put some weight inside this, I immersed a object of this volume. Okay. So it will increase the level of water, definitely. We will see that the level of water will increase. So how much water has been displaced? This water. The water level that has been raised, this water has been displaced. Now, whatever this is, whatever level this is, whatever volume of water is this must be having some mass. Yes, water is a matter, it definitely has a mass. And if it has some mass, it will also have some weight. Okay. M is the mass of this amount of water. Okay. So the weight of the liquid displaced is equals to the weight of the this liquid that you can see over here. Okay. And the buoyant force is equal to the weight of that fluid which has been displaced by the object. Yes. So suppose this is I'll take the same example. This is the piece of solid. It has a volume of 200 centimeter cube. Okay. It has a volume of 200 centimeter cube. So how much volume of water it will displace? It will displace, it will displace, what is its volume? 200 centimeter cube. So it will displace the volume of water equal to its own volume. Okay. So it will displace 200 centimeter cube of water. Yes. 200 centimeter cube of water. Now, what is the weight of 200? What we need to find? We have to find the how much buoyant force is acting. How much buoyant force is acting on this. Okay. But we already know from Archimedes principle that the buoyant force is equals to the weight of fluid displaced. We only know that what is the volume of liquid displaced, but we don't know the weight of water displaced. Yes? Come on. Do we know about density? I hope everyone knows about density. Yes. Density is equals to mass upon volume. What is the density of water? What is the density of water? We already know that the density of water is 1000 kg per meter cube. And with the help of this, we can find out the mass of water displaced. What is the volume of water displaced? It is 200 centimeter cube. What is that? Centimeter cube. But what is the SI unit of volume? Meter cube. So do you think that we have to convert this into meter? How can we convert centimeter into meter? By dividing it with 100. But this is not centimeter. This is centimeter cube. So we will divide it with 100 into 100 into 100. That is 10 lakh. So we'll say divided by 10 lakh. Can I also write it like this? Definitely. Okay. Now let's talk about the mass of fluid displaced. Okay. So to find it, we will do a cross multiplication. Mass is equals to, okay, 1000 multiplied with 200 into 10 to the power minus 6. What does this minus 6 mean? Minus 6 means, we can also write it like this. 1, 2, 3, 4, 5, 6. Yes. Now let's do the cancellation. 1, 2. This much has been cancelled. We got 2 upon 10. That means we got the mass equals to 0. Okay, sorry. Yeah, 0.2 kg. Getting it? So this much water has been displaced. We know the mass of the water. Now, can we find the weight of the water that has been displaced? Yes, the weight of water is mass with acceleration due to gravity. Let's take g equals to 10. So 0.2 multiplied with 10, we got 20 Newton of weight. This much weight of water has been displaced. So what is the buoyant force? Buoyant force is equals to the weight of liquid that has been displaced. That is equals to 20 Newton. Okay. If anyone asks you in which direction it will act, you will say 20 Newton opposite to the weight of the substance. So this 20 Newton force will act upwards on this object. Okay. So getting it? This is how we can calculate buoyant force. Okay. We'll also do some more questions in different domains. First, let's just talk about the Archimedes principle. So when a body is immersed fully or partially in a fluid, it experiences a upward force, the buoyant force, and that is equals to the weight of fluid displaced by the object. The more fluid it will displace, the more buoyant force it will experience. So let's take you to the example that we have discussed. Yeah, this iron sheep. So in this iron sheep, the volume of this iron sheep, the volume of liquid that it is displacing, the volume of liquid that it is displacing is more. Okay. So in this case, displaced water has more weight as compared to the iron sheet of the same weight. Okay. Displaced water is having more weight. Okay. So if it will displace more water, the more buoyant force would be acting on the sheep as compared to the sheet. Getting it? So this is how we can relate Archimedes principle with real life example. Now some more real life examples of Archimedes principle are: it is used in designing ships that we have just discussed. Okay. And also submarines. When we talk about submarines, how we can put the submarine uh, below the level of the sea, and how we can bring it up by if we will increase its weight, it will go down. Okay. And if we will release the water, it will go up because the buoyant force will act upwards. Now next is lactometers. This Archimedes principle is being used to design a lactometer as well. This is lactometer, which is used to determine the purity of the sample of milk. Okay. Next is you could say hydrometer. Hydrometers are the device which is used to determine the density of different fluid, and it is mostly used in determining the density of fuels like petrol, okay, like diesel. When you go to the petrol pump, you might see that there are two sections: cost and price, and then there's one more section that is density. Okay. So if the petrol is more than 750 gram per centimeter cube, okay, or 750 7 0.75 kg per centimeter per meter cube, then only it is good petrol. So basically, hydrometer is used to determine the density of different liquids, and also to determine their purity. Okay. So these are some applications of Archimedes principle. Come on, let's do a quick learning check. In what direction does the buoyant force on an object? Okay, take a deep breath. I know that you have did a lot of things. In what direction does the buoyant force on an object immersed in a liquid act? Oh, that is something very simple. In which direction is that does it act? So we can say buoyant force acts in a direction opposite to the weight of object, or you can also say in upward direction. Okay. Next. Very good. Okay. The question is the volume of 50 gram of substance is 200 centimeter cube. Let's take that substance. Let me make that substance. So this is 50 gram. The mass is 50 gram. Let's make a bigger one. We have a lot of space over here. 50 gram is the mass of this object, and volume is equals to volume of this object is 20 centimeter cube. Okay. Will the substance float or sink? So how can we determine whether it will float or sink? There is something. If the buoyant force, okay, we could say if the buoyant force is more, if the buoyant force is greater than weight, then it will sink, that it will float. And if the buoyant force is less than uh, weight, it will sink, definitely. Okay, so we know this. Come on, let's check what is the buoyant force acting on it. Mhm. First, let's talk about the weight of the substance. Let's take G equals to 10 meter per second square. Okay. So the weight equals to mg. That means 50 gram. First, we have to convert into kilogram, and then we have to do this. The weight is 0.5 Newton. Yes. Okay. We can also find out whether it will float or sink with its density. Come on, we know the density thing. Okay, let's make it easier. Let's find the density of this object. No problem. Density equals to mass upon volume. The mass is 50 gram. Okay, and the volume is 200 centimeter cube. Okay, let's talk about it. 200 centimeter cube. Okay, cancel 0, 1 upon 4. We got 0 point 0.25 gram per centimeter cube. Yes. Over here also we got two. Okay, wait. I think we had to consider this also. Okay, it is not 200, 2,500. It is uh you would say 1, 2, 3, 4. Okay, yes, it would be something like this. Mhm. So yes, over here we also got to see that the density of this object is actually less than the density of water. What is the density of water? Density of water is equals to 1 gram per centimeter cube. So yes, if the density of the object is less than water, it will definitely float. Okay, so the density of object is less than water, and that is why it will float. Getting it? Also, in kg per meter cube, you can also see the density of water is 1000 kg per meter cube. So again, the density of the object is less. That's why it will float. Let's move ahead of this. Okay. Let's move ahead of this. I've got one more question, and that is very conceptual. Okay, this is based completely on NCRT syllabus, so everything you get from NCRT only. Your mass is 42 kg on a weighing machine. Is your mass more than or less than 40 kg, 42 kg? So when you measure your mass, okay, your mass is 42 kg. Mhm. You actually measure the weight, and then that weight is converted into mass by the weighing machine automatically. Okay. So your mass is 42 kg. But if I talk about it, you are actually living in air. You have air all around us. Yes. And this air will also, air is what? Air is a fluid. Air is a fluid. Okay. So every fluid applies an upward force on an object immersed. If you are living in this atmosphere, you are actually immersed in this atmosphere. So this atmosphere will also apply an upward force will also apply a upward force that is also called buoyant force. Okay, buoyant force. Okay, due to which, due to which the weight of yours is reduced a little bit. Okay, and due to which your mass. Okay, suppose if there is an object, one force is acting here, the weight, and if it experiences some more force up in opposite direction, that is buoyant force. Okay, then the weight, the effect of weight will reduce a little bit because we are experiencing a opposite force. So the weight will decrease. In actual, the weight that we measure at weighing machine is less than our actual weight because we are in an atmosphere of air. The air will apply an upward force, okay, and due to which the weight reduces. That means your actual weight, if I talk about actual weight, is greater than the weight measured on the machine. Why? Because the weight measured on the machine also includes the opposite buoyant force due to air. Okay. So your actual mass is also greater than the mass that you measure. So actual mass of that object would be greater than 42 kg. Okay. Similar question. If you have a bag of cotton and iron bar, each indicating a mass of 100 kg. Okay. You have cotton and you have iron. Okay. Both have same mass when measured on a weighing machine. In reality, one is heavier than other. But in reality, not all of them, not both of them are having equal weight. Okay. Can you say which one is heavier and why? Come on. Let's talk about 100 kg of cotton. To assemble 100 kg of cotton, I think you need a bigger bag. But if you talk about 100 kg of iron, that could only be collected in a small piece because iron is heavy. Like if we talk about iron, iron has more density. Okay. So that is why a small piece of iron, if you take this small piece of iron, this much, it would be like around 5 kg. Okay. But if you take the small same piece of cotton, it would be like 50 grams only. So for same amount of cotton and iron, the cotton will occupy more volume. Yes, do you agree with me? Definitely. The cotton will occupy more volume as compared to iron. Yes, as compared to iron, the cotton will occupy more volume. So that is why if more volume is occupied, it will displace more air, displace more air. Yes, we already learned from the Archimedes principle, more the volume of the object, the more volume of fluid will be displaced. And if more volume of air will be displaced, the more buoyant force would be acting, the more buoyant force would be acting on the cotton bag. But, but you see that both are 100 kg on the weighing machine. Okay. Both are applying the same weight because weight is what? Mass into gravity, acceleration due to gravity. Weight is same. But here, the buoyant force acting on cotton is more, and the buoyant force acting on iron is less. The upthrust you say is less. That means the cotton is experiencing more force. Okay. And the iron is experiencing less force. Okay. Still, they have the same weight on the weighing machine. That means the actual the actual weight of cotton was more than the weight of iron. Why? Because cotton is experiencing more buoyant force. Okay. That means, suppose if they both are like 5 and 5 Newton force. Suppose, just suppose. And here you are experiencing 3 Newton buoyant force. Here you are experiencing only 1 Newton buoyant force. Okay. So the weight here would be, the actual weight here would be 2 Newton. Okay. And the actual weight here would be, okay, the weight on the weighing machine would be 4 Newton. Are they equal? No. To make them equal, this should be also more. This should be equals to at least 8 Newton, sorry, 7 Newton, so that the effective weight could be same. So if this would be 7 Newton, now you could say that yes, both are equal on the weighing machine. So cotton is actually experiencing more buoyant force and iron is experiencing less buoyant force. Okay. So that is why the actual weight of cotton would be more because it is experiencing more opposite force. So to counter that opposite force, it should be more in weight. So in this question, can you say which one is heavier? You will say that 100 kg of cotton is heavier than 100 kg of iron. Okay. Why? Because the 100 kg of cotton have more volume. It will experience more buoyant force. Okay. And if it experience more buoyant force, that means the actual weight of the cotton, 100 kg cotton would be more to make them equal on the weighing scale. Getting it? So this was a very good question. It's one of the cream questions of NCRT. Okay, and it involves a lot of conceptual understanding of buoyancy, density, Archimedes principle, and all. So this is all about today's class. It was quite a long class. Okay. So I would like to say a big, big thank you for all the subscriber. If you are new to this channel, go and subscribe it. Go and share it with your friends. It's very important to get the detailed knowledge of all these concepts. Okay. If in case you want any more videos on the same topic, do let me know. Okay. So you can follow the channel Teach AR where you can get all the exclusive contents of grade 9, 10. Okay, we are also coming with more series, more classes. Okay. So yes, after this we'll start with work and energy. Definitely it's a request from one of my students. So thank you so much. It's so good to have you. In between, I didn't posted some videos just because I was also going through my examinations. I was doing masters in physics, and that's why I was having some examinations. We'll see you again in the next video. Let's spread this channel out, subscribe it, share it, and definitely like if you like the content and my teaching. So bye bye. Take care. Have a good day and good life. Stay healthy, stay fit, keep on studying.